In this video, we are going to study about batteries. Batteries are a group of cells suitably arranged to get a maximum current, means strong current. Many ways batteries can be grouped. Batteries are used to apply an EMF, I mean potential difference across a circuit. There are so many terms related to this topic. For example, EMF of a cell, terminal PD, internal resistance, and then last we will discuss combination of cells, series, parallel and mixed. A number of cells when suitably connected, the arrangement is called battery. EMF of a battery is the maximum potential difference between the two terminals of the battery. Two terminals of the battery means the two electrodes of the battery when the cell is in the open circuit. Cell in the open circuit means when no current is drawn from the cell. No current is drawn from the cell means through an external load, current is not made to flow. It is called EMF of a cell. Right? It is the energy supplied to the cell to drive unit charge once around the complete circuit when external resistance equal to 0. This is what is called EMF of a cell. EMF is measured in terms of volt only. Expression for EMF is this one, because E dot dl we know potential difference. Potential difference through the entire complete circuit. That is why integral line integral of the entire closed circuit, E dot dl it is written, right? E dot dl means it is the potential difference to a small length, a small path of the electric circuit. Through the entire path, the total potential difference is integral E dot dl. E dot dl, everybody knows it is potential difference. E dot dl is the potential difference for a small path of the electric circuit. So, for entire circuit, the whole entire closed circuit, entire circuit, the EMF total potential difference is given by EMF. EMF is actually potential difference only, but it is the potential difference between the two terminals of a cell when no current is drawn from the cell. It's E is the electric field. In this E is the electric field and dl is the small path segment. Okay. Unit of EMF is just like a potential difference only. It is volt. If a cell supplies 1 joule of energy to drive 1 coulomb of charge around the circuit once, then the EMF of the cell is equal to 1 volt. This is about EMF of a cell. Now we have to discuss what is internal resistance of a cell. Internal resistance of a cell is the resistance offered by the electrolyte of the cell, because cell has an electrolyte. For example, simple voltaic cell has electrolyte as sulfuric acid. H2SO4 is the electrolyte used. So electrolyte means, suppose H2SO4 when dropped in water, at first it dissociates into 2H positive plus SO4 double negatives. That means ionization takes place. We have already discussed that in electrolytes the charge carriers are ions, right? So due to the ionic motion in the solution, there is a resistance offered. That resistance is called internal resistance of a cell. Internal resistance of a cell is also measured using the same unit ohms, right? Internal resistance most of the time is represented like this. Cell means how cell is represented, a long line and a short line. It is denoted by the small letter r. Small letter r, right? Now, factors affecting internal resistance of a cell. Factors affecting internal resistance of a cell. The first point is the distance between the electrodes. When the distance between the two electrodes increases, then internal resistance also increases. Right. Nature of the electrolyte also affects the internal resistance of a cell. The next is concentration of the electrolyte. So concentration of electrolyte means first of all the cell makers make the solution of a particular fixed value of a specific gravity. That is the concentration. Concentration is very necessary. Right? Cell makers know it better. Which cell, what concentration the electrolyte has to be used. So concentration of the electrolyte when increases, the internal resistance also increases. Next is nature of the electrodes also play a great role in the internal resistance of the cell. Fifth is area of the plates. Area of the plates when increases, internal resistance decreases. Internal resistance decreases with the increase in area of the plates. Alright. The last is temperature. Temperature of the atmospheric temperature, the surrounding temperature of a cell when increases, internal resistance actually decreases. That is why in the morning hours it becomes very difficult to start a car because the self does not work properly. So in cold days, mainly in cold days, in winter days, early in the morning to start a car or any motor vehicle, it feels a bit difficult because the self is operated by a DC battery. DC battery, when temperature decreases, atmospheric temperature decreases, then the internal resistance increases. Hence, the proper value of terminal PD the motor does not get. That is why it becomes very difficult to start a vehicle in the morning. But when time increases, at about 9 o'clock or 10 o'clock, the atmospheric temperature increases and the internal resistance decreases. It becomes easy to start a vehicle. So this temperature is also an important point, right? Temperature is also an important point, right? Okay, right? Okay. Now relation for EMF. Relation for EMF, we have this relation, this diagram you will see. Here this is a cell and this is actually the internal resistance of cell. You have to mark here R. I forgot to mark R here small r because internal resistance is denoted by small r. And now this cell with internal resistance R is in the open circuit. Open circuit means maximum EMF is obtained, right? Maximum is obtained. And in this case you will see the cell is in the closed circuit. Closed circuit means an external resistance is applied there. And this is the closed, this is in the open circuit. Open circuit means current is not delivered by the cell. Closed circuit means current is delivered by the circuit. From figure 2 we can write I is equal means total current is equal to total EMF divided by total resistance. So this is a common relation always we use. What is this? Total circuit current I is equal to total EMF divided by total resistance. Total resistance is equal to external resistance plus internal resistance. That is equal to that is IR plus small IR is equal to capital E, right? But small I into capital R is equal to V. I into capital R means when current flows through a resistance capital R, resistance R, potential difference across the wire is equal to IR. IR is potential difference. Potential difference sometimes called as terminal PD of a cell. So in place of IR we can put capital V plus I into small r is equal to capital or V is equal to E minus IR. So in this case you have to remember one thing that when a cell is used, its EMF always remains a constant. But terminal PD varies with the change in the value of internal resistance. So IR is equal to E minus V or small r is equal to E minus V divided by capital I, right? But by Ohm's law we know that I is equal to V by capital R. When current flows through a conductor of resistance capital R, then current I is equal to V by R. So in place of I, we put V by R. R goes in the numerator. That is small r is equal to E by V minus 1 into R, where R is the external resistance, V is the terminal PD of the cell. Terminal PD means the potential difference, actually the useful potential difference. That means we are giving potential difference to an external load. The load gets the potential difference or the energy is equal to V only. But actual energy of the cell is E. Some amount of energy of the cell is used for overcoming the internal resistance of the cell. So that is why we write what you call V is equal to E minus I into R. So E is equal to EMF of the cell. When the cell is in use, EMF is always greater than the terminal PD. T is terminal PD, right? That is, V is always less, EMF is always less than terminal PD. You know it because V is equal to E minus something. What is that something? That is the energy used by the cell to overcome the internal resistance. What is that? That is equal to I into small r. When the cell is in the charging process, sometimes there are two kinds of cells we have. One is simple cells. Simple cells means primary cells, we will say. Other one is called secondary cells. Primary cells are not necessarily to charge it. Once the primary cell is made, we can use it directly. But secondary cells like acid cells, alkali cells, etc. First of all, the cell is made, constituted, then it is put for charging about 24 hours, 48 hours, etc. In this condition, electrical energy is first stored in the form of chemical energy. Then that electrical energy first formed as chemical energy. Then the chemical energy is again converted into electrical energy when the cell is discharged. So in the charging process, always remember terminal PD is greater than EMF of a cell. Question can be asked: can the EMF of a cell greater than the terminal PD? Yes. In what condition? When the cell is in the charging process, the EMF of the cell is less than terminal PD. Terminal PD can be greater than the EMF of the cell. All right.